Welcome to Master of Science with host Professor James McCanney. The good professor's career spans 50 years as a university teacher, scientist, and engineer. Each week, he will explore the rapidly changing world of science as many long-held theories are crumbling under the weight of new data. He will cover the fields of geology, archaeology, meteorology, oceanography, space science, astronomy, cosmology, biological evolution, virology, energy, mathematics, and more. So please welcome the host of Master of Science, James McCanney.
Good evening, everybody, and welcome. And tonight is a very special night. It's a topic that I have a lot of experience in. And let me go back, give a little bit of history here. In the early 2000s, like the year 2000, I realized that in the future, the new millennium, the new century, the new year, that the most important things on planet Earth were energy, water, food, and this is a list somebody made up, humanity's top 10 problems for the next 50 years. So those are the top three. Then environment, poverty, terrorism and war, disease, education, democracy, population. You could roll these in any order you want, but literally everything depends on energy. And say you buy a hot dog at the ballpark and it costs you $3. The actual value of that hot dog might be in the few cents region. From the time it is grown on the farm and then processed, then taken to market, then everything that goes into making that hot dog, most of the cost is energy. So if you could take and reduce the cost of energy by 50%, which has been done in other countries, I won't go into that political mess, but the cost of energy is kept artificially high by people who make a lot of money off of energy. And so all of the other resulting things we need, water, food, all of these things take energy unless you live completely off the grid but for the vast majority of people, the energy cost factors into almost everything you do, buy everything you do. So if you could reduce the cost of energy, that would be a good thing, beneficial for the economy, because really when you pay for energy, it's something that is there, you use it, and we think about renewables. That's a great idea. But I'll be talking tonight also about a topic I pioneered in the very early 2000s. I was on major radio shows talking about the myth of alternative energy, and it really is a myth. And when I start explaining this to you, you'll understand. But what I did is I decided I wanted to put myself in front of those three branches of the economy: energy, water, and food. And now I'm there. I'm actually there. I've had my water filter company for 24 years. The wing generator has been active since around the year 2004. And I wrote a book, which I'll show you. The cover here is the McCanney World Energy Project, and talks about the wing generator, which is a patented device that I have 2 patents on and more on the way. But the idea is that, and then also food, I have the grow towers. But this is not a commercial about products or trying to sell you something. This is about the history of energy over the last number of decades. So let's just go through some of these slides. So just notice this, that the top 50 problems you could list out, the top 10 problems. But if you go through all of them, energy is involved in all of them. In fact, if you look at terrorism and war, most of the wars are over energy and resources, and environmental issues. Good grief, the list just is very dense here. Disease, education, poverty, democracy, population, etc. Okay, the next slide shows a graphical image of the world and the problematic areas regarding water. Now, look at the United States. You'll see that the entire eastern part of the United States is severely threatened, and most of the United States is up in the high range where water is a real problem. Look at Europe. You can look at the developed countries of the world. And then you go to high population areas, of course, like China, India, and Malaysia. But some of the really good areas of the world are in third world countries where they have excellent water, something that the first world countries do not have. Now, this slide, look at world energy. The current wind and solar will not solve our problem. And look at the current amount of energy that is produced by wind and solar. And the government is dumping trillions of dollars into technologies that simply will not work. And that's what the main topic of this show will be about. But look at how little of the world's energy supply is provided by wind and solar. So people who are tree huggers, and I myself am a tree hugger. I'll just be very frank about that. I am very much in favor of the environment, trying to solve economic problems, etc. But the way the current situation is with alternative energy, it simply won't work. So let me go back in history a little bit. About the year 2004, I was hired as a physicist, as an engineer, to do an energy analysis of a company called Xcel Energy. It's up in the Midwest. And they have a multi-state distribution of energy. And I was doing this for a company that was involved in biodegradable energy sources that they were using to make into biofuel. And so they wanted to just understand the dynamics of energy and energy distribution the way it was at the current time. So I looked into that, and I was, in a sense, horrified by the amount of energy that is wasted simply in producing 1 kilowatt of electrical energy. A lot of waste, because here's the problem. Anytime you burn something, and people come along and they say, oh, well, the thorium reactor, a fusion reactor would solve all the world's energy problems. And the answer is no, it wouldn't. Because you're taking some inert material, you're heating it up, creating heat, and then about 75% of that heat goes directly into the atmosphere, and only about 25% actually creates useful electricity. Or if you're burning it directly, like in a gasoline engine, or a diesel engine, probably about 25% of it after the mechanical losses, etc., sometimes less than that. Very little bit of that burned energy is actually converted into useful work. Something that lights a light bulb or toasts your toast or whatever. And the same with nuclear fuel. Albert Einstein had a quip. He said that nuclear power, when asked about using nuclear power for energy, for creating electricity, etc., Albert Einstein said, nuclear energy is a very poor choice for heating your coffee. That was his quip before he died, 1954, I believe, or 55 when Einstein died. But the end result is that the way energy is produced today, taking inert materials, whether it's coal, oil, gas, natural gas, petroleum products, nuclear, and biodegradable biomass. Geothermal is another one where you're taking heat that's trapped in the earth, you're bringing it up and converting it into usable energy, but about 75% of that is lost. So you're bringing up heat from inside the Earth that normally would not get out. It would be trapped in there. And once again, about 25% of that is actually converted into useful energy. But I'll get into this a little bit later. If you're driving an electric car and you're charging it from the plug on the wall, it's primarily coming from fossil fuels of some kind, and fossil fuels is a misnomer of the highest caliber, because the petroleum and coal, etc., don't come from decaying dinosaur bones, as somebody tried to pawn off on the public back in the early 1900s, and that term is still used incorrectly. It's a terrible term, but everybody knows what it means. Coal, gas, petroleum-based product. Okay, so now going on. And by the way, if you're listening to this on a podcast, an audio podcast, you may want to check out the video podcast of this same show, because there's a lot of visuals on this show, this particular one. Okay, so I happen to have a product. It's called the JMCC Wing Generator. It's patented, trademarked, and I call it, the motto is the jet age of wind energy. But here is a image of the wing generator working, and in the 2018 I was elected or nominated for the X Prize Technology Innovation Achievement Award, and was a finalist in what is known as the Water Abundance X Prize, which the goal was to extract water from the atmosphere for less than 2 cents per liter on an ongoing basis. And this is a photograph of the actual installation in Hawaii at the research center that was the installation that won the finalist prize. Here is a visual of a gas station, or actually an electric charging station, which could accompany a gas station, using a 250 kilowatt wing generator to power the electric charging station, with an estimated 95% of the energy coming from wind. And now the companies are divided into 3 sections: small, medium, and large, with the small going from 2 to 250 kilowatts. The medium, called medium commercial, goes from 10 to 25 megawatts, much larger than the current 3-blade wind turbines that are on the commercial market. And then the large ones, this is the issue here. The very large ones can scale up to 250 megawatts or beyond. Now, this is what separates this device from the other ones, from anything you'll see on the commercial market today. And I'll give examples of comparison between this and, for example, 3-blade wind and solar, and showing how the this is a much more economic solution because it is scalable. And here's the issue. The solar and 3-blade wind turbines, those things that are out there scattered all over the countryside, which don't work, the wind blows right through them. They can only go up to about 10 megawatts, and that's about as big as they're going to get. Also, there's an issue with a company called General Electric and Siemens, in which they are the primary promoters of 3-blade wind turbines, and the end result is they have a product. Their main product and product line is dealing with central companies' power, electricity. And so the wind turbine business is very strange, because in a world needing energy, in which energy is very expensive, they cannot even succeed with government subsidies. So I'll be talking a little bit more about that. Now, here is a picture of the wing generator at the lower left. And above, I want you to take a quick look at all of these different types of wind generator systems that have been built over the past 5,000 years. And they have done a lot of work in the Netherlands, for example, Or in Spain, you go back to the Middle Ages, you had sawmills, grit mills that were grinding grain, etc., using windmills. So there's a couple of those. And then you see the variations of the 2-blade, the 3-blade generators, etc. All of these different styles of wind generators, and all of them basically failed. They produce a little bit of energy, but not very much. And so the wing generator has 24 improvements over 3-blade wind turbines. And this is a list of them. So I'm going to go through this because it's very important for people to understand that when you see those 3-blade wind turbines, a field of them out there, and there one or two of them are spinning, it turns out that they have an electric motor inside of them. And that electric motor is what's causing them to spin, not the wind. And it takes a very strong wind for them to move. They cannot start on their own, and they have a cutoff velocity, wind velocity, that's very low. And so there's a very narrow range of wind speeds in which they can function. Okay, so now I'm going to go through the 24 improvements of the wing generator over the 3-blade wind turbines, the wing generator on the left and the 3-blade wind turbine on the right. The wing generator captures 95% of the wind energy that's coming into its field, whereas the 3-blade wind turbines only capture about 5%. In other words, 95% of the wind actually blows through them without ever touching the blades. How can they capture energy? That's absolutely absurd. The wing generator has aerodynamic lift that's in the rotary direction, whereas the aerodynamic lift on the propellers, they're like propellers, is perpendicular to the rotary direction. So it actually pulls against the tower, causing tremendous stress on the tower. There's a high torque at the outer edge of the wings, and the wings get larger as they go out towards the outer band, and therefore that's where the majority of the lift occurs, that's where you want it, because torque is a relationship between the radius and the force at the outer edge of the curve, and that's what the situation with the wing generator. Whereas the 3-blade wind turbines, it's skinny little tip, and so there's hardly any torque generated at all out at the outer tip of the 3-blade wind turbine. The shroud, this is part of the patent, by the way, is that the shroud at the outer edge of the wings maintains the air flow coming across the top of the wing, whereas with the 3-blade wind turbine, the wind slides off the tip and it's not contained. It actually doesn't do anything at all. The wing generator uses the principle of a jet engine, whereas the 3-blade wind turbines use the principles of propellers. So it's literally, the motto is like the jet age of wind energy, using the wing generator. The wing generator is self-starting in very low wind speeds. It starts by itself. It does not need an internal motor to get it moving, whereas the 3-blade wind turbines have a motor inside that actually take electricity off the grid to get them started. This is something a lot of people don't know. The wing generator is 50 to 80% efficient. In other words, the wind coming in is going to be converted at a high rate, whereas the 3-blade wind turbines have about a 20% efficiency. This is very interesting. The wing generator is ultra light. So what you see there does not weigh much at all, whereas the blades on the 3-blade wind turbines can reach 65 tons, if you can even imagine that. That's why they have a lot of failures. And the materials in the wing generator are purposefully designed to be recyclable. And the 3-blade wind turbines, that's one of the big problems you're starting to see today, is when the 3-blade wind turbines fail, which a lot of them are, way before their anticipated lifetime, and they take these huge blades and they just dump them in a field someplace because there's really no place to put them. So anyway, that's one of the issues. And by the way, I'll just go through a little bit of a history here. I was talking about the company that I was hired to do an energy analysis of Xcel Energy. And so I did the study, and like I say, it was for a biofuel company that wanted to understand the efficiency of creating electricity and the use of energy, etc. And at the end of the study, they said, why don't you also take a look into this 3-blade wind turbine, alternative energy, and solar panels to do an analysis on these and see what their potential is, etc. So I did, and this is back in 2004, before any of this really took hold, before any of the big installations came along. And I did a physics analysis of these technologies, and I said they don't work. They're never going to work. And the bigger you make them, the worse they're going to get. They don't scale. They're not scalable. And the reason that solar panels are not scalable is, number one, they're low voltage. So to make a lot of power, you have to connect thousands and thousands and thousands, tens, hundreds of thousands of them together. And out in the environment, those connection points are a problem. If you don't believe me, just ask, I think it was Amazon. Amazon was going to go green, and they put solar panels on the roof of their warehouses, and pretty soon they started having fires. And the reason is those connections, those low voltage connections, low voltage, high current, once they start corroding, they become a high impedance junction, and they start heating up, and they cause fires. And so they had to shut all of that down. And then the other issue with the 3-blade wind turbines is they don't scale up. The biggest they can make them is only about 10 megawatts. That's why the wing generator is designed to go up to sizes that would replace nuclear and coal power plants with a single unit. And so that saves on footprint. You don't have these fields and fields of 3-blade wind turbines all over the place. You just have a few large ones that can be out of sight, out of mind, and typically offshore. Okay, so by the way this began, when I finished my study for this company, efficiency study, I sat down, I said, good grief, the problem with solar is not going to be overcome because solar panels are low voltage. You're going to have, cover entire states with them. But the big problem with solar is the sun only shines during the daytime. And I don't care where you live, if you live in the middle of the Sahara Desert or the sunniest place on the planet, the sun goes down at night. And so the problem is, then you need batteries. Okay, now you need batteries, but also you have to put in a lot more solar power to charge up those batteries so you have electricity during the nighttime. And so the batteries are extremely expensive, and that cost is not going to go down. And there again, you have the scalability of trying to solve the world energy problem. So this was my main primary focus. My main question was, will this technology solve the world energy problem? That's the sole criteria. The sole criteria is, will the technology solve the world energy problem? And so what I did, based on my engineering background, I'd been an engineer for 25 years in the various electronics industries, etc. And when you have a new product, you have or a concept, you write a functional specification. And I was a principal systems engineer in a very large electronics company called AT&T. And my designs would then be taken by the engineering staff and the software developers and incorporated. So, but what the functional specification was, It didn't say how big it was or what. It didn't say anything about really what it was, other than this is what it has to do. This is what it has to do. And so when I'm reading you these 24 improvements of the wing generator over 3-blade wind turbines, this comes from my functional specification that I drew up for wind energy systems, because I knew solar would never work. Solar is not a solution for the world energy problem. There is abundant wind, there's abundant solar, but it's just that you have this day-night problem. With wind, the wind blows day and night, so you don't have that issue. There also, I'll show you a map in a minute, of the United States, for example. We know where the wind blows. It blows very hard all the time in certain places. You go to certain places. I remember driving out to Laughlin, Nevada from Texas. I was going to one of the UFO congresses where I was giving a talk. And there was a place, I think it was in Nevada, like this valley. And I mean, you get out of your car and the doors come off the car. The wind is just non-stop there. So we know where the wind blows, but we have to have large installations to capture that wind and then feed it off to the rest of the country. So wind is the solution. Wind is the alternative energy solution, but the 3-blade wind turbine simply does not work. So I'm going to continue with my list here, but the point is that when I wrote my functional specification, before ever taking a slide rule and a ruler to a piece of paper to look at his design, here's what I said it had to do. Okay, so I'm going to continue. This is page 2 of the list of 24 improvements of the wing generator over 3-blade wind turbines. Scalable to 250 megawatts, the wing generator, whereas the 3-blade wind turbines, the biggest they're going to make them is 10. There's some 14 megawatt models out there, but they're not going to be mass produced. Small footprint. Okay, so if you can scale a wind unit up to 250 megawatts, that's huge compared to having fields and fields of these 3-blade wind turbines. So it is a small footprint for the amount of energy you're getting. The wing generator, the design grows in 3 dimensions. As it gets radially bigger, as the diameter of the drum gets bigger, it grows in 1, 2, and 3 dimensions. So very important, whereas the 3-blade wind turbines only grow in 1 dimension, and that's that long, skinny blade. Okay, this is a huge one. This is huge for the environmental interest. That birds and bats see it, it's eco-friendly, and the birds and bats fly around it. They can see it. Whereas the 3-blade wind turbines, they can't see those blades coming around, and the eagles are killed, the hawks, the migrating birds, because they put them in these passes where it's windy, and that's also the migratory path for these birds. So they killed bats and birds by the thousands. It's a horrific issue with the 3-blade wind turbine. The wing generator does not do that. And I've been on installation sites with the wing generator. Once I saw a bird come up to it and looked at it and actually hovered and then flew around it. Birds and bats see them and detect them and do not fly into them. The wing generator is a low RPM, and so this is the internal part, is low RPM. So you don't have that high frequency EMF problem that affects people that are near it. Whereas the 3-blade wind turbines have a transmission inside that causes them to generate very high frequency EMF and cause problems with people that live near them. This next point is a huge one, that all the heavy equipment is on the ground with the wing generator. So you can see my functional specification coming out in this list of improvements. whereas all of the heavy equipment in a three-blade wind turbine is up on the top of the tower. So when you maintain it, you got to get up on the tower and lift it with cranes. It's horrifically bad. Offshore, you would put the wind generators, the wing generators, offshore on barges. Whereas the three-blade wind turbines, they have to build these massive pillars, and the fishermen are going crazy because it ruins their fishing, because all the fish are confused, and the whales, excuse me, swim into this area and they're confused, and a lot of times they end up being beached, etc. So the three-blade wind turbines offshore are an environmental disaster, although nobody really is talking about that. So the maintenance of the three-blade wind turbine is horrific. You got to take a boat out there and anchor it and get people up on a crane up on top of this, and the water's moving. It's horrifically bad. Whereas the wing generator is put on a barge, and you just bring the barge into shore, do all the maintenance, which is on the barge itself. And the wing generator, you can do all the maintenance from ground level. That's the way it's designed. So the maintenance is very easy on the wing generator. It is horrifically bad with the three-blade wind turbine. Okay, so this is an interesting one. 15% on the wing generator, 15% of the materials are in the support structure. On the three-blade wind turbine, 90% of the materials are in the support structure. Horrific amount of support structure to hold this little teeny generator, which cannot grow over 10 megawatts. The wing generator is available in small, medium, and large sizes. The three-blade wind turbines abandoned the smaller markets. And so for the average person on a farm or ranch, etc., they are not able to access wind energy. Here's another huge issue, is that the wing generator works at low and very high wind speeds, and a very wide spectrum of wind speeds, whereas the three-blade wind turbines have to shut down at over about 33-mile-an-hour wind because they literally come apart at the seams. The wind alignment system for the wing generator is very simple, and I'll be showing some videos here where you'll see the wing generator reacting to the wind and the gusting wind, and it's changing direction. It's a very natural. There's no equipment, there's no electronics, it does it naturally. Whereas with the three-blade wind turbines, you have this extremely complex set of electronics that changes the blade pitch and changes the direction, and it's very complicated, and it really doesn't work that well, and it does not work well in gusty winds. There's a 50-year life cycle for the wing generator and a less than 15-year life cycle for the three-blade wind turbines, and the three-blade wind turbines are failing at a tremendous rate. So the biggest issue here is, will this technology solve the world energy problem? And the answer is that the wing generator will, and the three-blade wind turbine will not. Now, if you can solve the energy problem, okay, next comes water. And I was a finalist in the Water Abundance X Prize. Apart from my water filter company, I have other technologies like extracting water from the air, and also desalination. And desalination, we live on a water planet that has lots of water, just that most of it has salt in it. So you have to get rid of that. And so I also have technologies run by the wing generator that remove salt from the water. So it's something that, as you can see, I've been working on. Okay, I'm going to talk a little bit now about the history of the three-blade wind turbine. This is where it all started. Is back in I believe in the 1970s. NASA was going to do a study on wind energy and come up with some kind of design that would be beneficial for the future, as this was where it was beginning. So they did some basic studies of small, very small three-blade wind turbines, which spin very fast because they're small. So they are very efficient, small three-blade wind turbines. I've actually sold those myself using 3 blades because they spin very fast. And here's the issue, that the blade coming around following the next blade, the space between them in terms of the air that's passing through is very short because it's spinning very fast. The problem is that the bigger you make the 3-blade wind turbines, the slower they spin. And that's just a physical reality because you can't make big things spin very fast. And the wing generator overcomes that because it's using a very different design. And so this, however, causes another major problem, even for the small, relatively efficient 3-blade wind turbines, in that the leading blade causes a great deal of turbulence, destroying the aerodynamic properties of the following blade. So it's a really kind of a catch-22. And there again, the wing generator solves this because when the air flows through the wing generator, it flows out the back side, and the leading wing does not affect the airflow of the following wing. So the entire issue with the 3-blade wind turbine is it is not scalable. You can make them up to 10 megawatts, something like that, but you need wind generators that are in the 250 to 500 megawatt range. 3-blade wind turbines will never, ever get to be that big because they're very inefficient. They're very inefficient. The bigger they get, the less efficient they can be because they spin, the bigger they are, the slower they spin. And they have real mechanical problems when they get big. In the size, the blades themselves right now are weighing in excess of 65 tons each. Absolute absurdity. So it should have been, this is one of the things you do. Say you're building boats or you're building airplanes, things that you want to make big someday. There's something called scalability. It's in mechanical engineering. It's in electronics. If you want to make something bigger, you have to be able to scale it up. And all of the factors in the system have to scale up. And so, like I say, when I designed the wing generator, I didn't sit down and design it. I wrote up all of the things that are wrong with the 3-blade wind turbine system. And I said, the new system has to overcome all of these things. That long list that I read to you came from my functional specification that I wrote up because knowing full well that the 3-blade wind turbines would fail. And that's what's going on. And so the end result is after I realized this, and so when I started designing the wing generator, if I varied outside of those parameters or those design parameters, then I'd say, oh no, this is not good. I got to get back to within these 24 improvements. And thus the wing generator was born. So now I'm going to show you a whole series of slides and talk about them. The first one deals with comparing the 3-blade wind turbine with the wing generator. The blue curve is the wing generator. Now this is the wind velocity response curve. And what this means is the wind speed at which the unit can efficiently produce power. And you'll see the red line is the 3-blade wind turbine. It's very poor at even mid wind speeds. It has a peak useful wind speed, and then it drops off completely because they have to shut them down. If they go any faster, they'll come flying apart. So it simply doesn't work throughout the range of wind speeds, whereas the wing generator is designed to work at a very wide range of wind speeds. Next, this is a comparison of footprints and other factors related to the JMCC wing generator, the three-blade wind turbine, and solar. This is for a 100 megawatt system. Now this would be a commercial system that would be large enough to power, say, a small town. And so the wing generator, 2 acres, we're talking about footprint. 2 acres for the JMCC wing generator, 375 acres for the three-blade wind turbine, and 600 acres for solar. The number of units to make 100 megawatts would be one of the wing generators, 125 three-blade wind turbines, or 600,000 solar panels of the 400-watt variety. Cost, $50 million for the U.S. dollars for the wing generator, $375 million for the three-blade wind turbines, not including batteries, and $720 million for solar. Here's another question: does it kill birds and bats? The wing generator, no. Three-blade wind turbines and solar. Solar, one thing people don't understand is when they put vast solar arrays out in the desert, about 80% of that heat is coming off and the birds fly over that and it kills them. So solar is not your eco-friendly solution, excuse me. The next thing, government subsidies. The wing generator, no, does not depend on government subsidies or buyouts or tax credits at all. It can make it on its own. Three-blade wind turbine, yes, and solar, yes. In fact, it's very strange that the three-blade wind turbine industry is failing in spite of the fact that energy prices are through the ceiling. It should be the most successful product on the planet, in failing in spite of the fact that they get huge government discounts and credits. It's unbelievable. So it's simply a product that doesn't work. The lifetime, the wing lifetime expectant lifetime 50 years. Three-blade wind turbines 15 years if they go to their full term. But right now about 40% of the three-blade wind turbines in the United States are not functional because they can't repair them. They have problems with their transmissions, a lot of other problems. And solar has, actually, I'm being generous here, it says 15 years. They actually have about a 10-year life cycle where they have to be completely swapped out because they lose efficiency over a period of time. And then overall efficiency, converting the energy source into usable energy, the wing generator between 50 and 80%, three-blade wind turbines about 20%, and solar actually about, I'm being generous here also, 20%, because what happens as solar panels get hot, which they do, they lose efficiency. So anyway, that's something to look at. Okay, just an example of production equipment with the wing generator, a photo here. So there's solutions for on and off grid, for farm and ranch, electric trucks and tractors, islands, eco villages. You can read the list here. Hydrogen, and the reason I have hydrogen here, that's where the wing generator industry is going. That's where this is headed. And the only interest I have at this point is to create hydrogen, because hydrogen is the future. If you can produce hydrogen from the wind and then recycle the water, this is a very interesting aspect of hydrogen, is that once you get the water purified and using it for the powering the whether automobiles or trucks or whatever, then you can recycle that water. When the vehicle comes in to be refueled, you have very pure water as a byproduct. Okay, so on and on. There's many other uses for the wind generator and hydrogen. Let me see here, having a little problem getting the slide there. Okay. Energy, water, food, local solutions. Now, this is an idealistic drawing here using the grow towers, which you can see in the upper right-hand corner, growing food. You have the wing generator in the background providing electricity and clean water. So all of this is an idealistic, futuristic city that really is something that is feasible. Here's a map, a wind map of the United States, and we have these maps for all over the world, but you can see the regions that have very high wind potential. And we know where the wind blows. We just have to get the right equipment in those locations to capture the wind and convert it into electricity. Electric transportation, cars, electric vehicles for delivery, motorcycles, trains have been electric since almost the inception. Airplanes, electric airplanes are coming along, and electric boats. This is all coming along in the near future. And like I said before, if your energy is coming from coal or some other fossil fuel, which is a misnomer, by the way, as I said, if your energy is coming from nuclear or coal, it is not green energy. And I just have to make a comment also. My advanced physics degree is in nuclear and solid state physics. And when people talk about nuclear energy being green because it doesn't produce carbon dioxide, nuclear power is one of the most horrifically bad, polluting forms of energy on the planet. Because if the problem is that the fuel, even if they're safe, which they're not, most of the installations in the United States, less than 100 now, are leaking in the ground. The pipes are leaking. They have no way of testing these. They're all hitting their limit of lifetime, and nobody's talking about this. They don't have the money to shut these power plants down. So they keep looking for money to try and keep them operating. They're way past their designated lifetime, and they're burning fuel that is what they call high octane fuel, nuclear fuel, that was never meant to be burned in these facilities. So the U.S. nuclear situation is horrific. And this is from a purely scientific engineering standpoint. Okay, so if you're getting your electricity from one of these sources for your electric car, it's not green, excuse me. Here's the cover of my book, McCanny Wing Generator, Distributed Energy National Grid. I was the first one to be talking about distribution of energy, alternative energy. But in this book, you'll see the subtitle with the supplement, The Myth of Alternative Energy. In the early 2000s, I started a campaign talking about the myths of alternative energy, of three-blade wind turbines and solar, as a result of this study that I was talking about, and tried to get the word out that the direction that they're going is really wrong. Here's the table of contents of that book, and you can see the various titles here. Chapter 9, The Myth of Alternative Energy, page 77. And here is the first page. Take a look at that if you have time. Stop the video and look. But the whole point here is that we knew back then, this is in the early 2000s, that this three-blade wind turbine and solar panel concepts would not power the world. And you could see by the chart I showed at the very beginning of this show, showing that even today, with all of the installations of wind power and solar, it's only about 1% of the world energy production. So how can you multiply that by, say, 100 and fill the world capacity for energy? It's just, it's not going to work. It's simply not going to work. And that's why I designed the wing generator as something that will work. And at this point, people are probably also asking, well, if it works so well, why isn't it being funded on a national scale, etc.? The answer is that the government protects the energy interests, and the energy interests are not interested in funding something that works. So when you see advertisements or you see YouTube videos or you see articles touting some new energy, alternative energy, things that bob in the waves or things that are like whatever it is, they get funded if they're not going to work. Anything that's really going to work is not going to get funded because the big money people, the people that really move the large amounts of money around the planet, are all heavily invested in standard forms of energy. And they don't want to see something that comes along that works. Why do you think General Electric and Siemens excuse me, are selling 3-blade wind turbines? Because it doesn't compete with their main core business, which is central power energy systems. So anyway, the myth of alternative energy, very complicated topic. Here's a slide that shows the Canadian wind energy group that is opposed to wind turbines. And they're all over the place, but you don't see them. They don't hit the headlines because the news media is very well controlled, especially when it comes to energy. These are engineering drawings that were early in the development of the wing generator, showing, you can see the little person over on the left-hand side there at the base, just giving you a feeling of scale. There's an artist's conception of a 100-foot prototype wing generation system, and of course this is just the frame. This is not the actual system with the wings inserted. And here's a scale from 100-foot tall to, you can see it growing in 3 dimensions also, up to 1,000-foot tall unit. And it is estimated with about, I won't give a final number, but the large 1,000-foot tall, 75-foot deep wing generators would be enough to replace, a single unit would be enough to replace a nuclear or coal power plant. Here's the Tesla Tower, and I wanted to bring this in because back in the 1990s, I had a project to reproduce the Tesla Tower and extract energy from the atmosphere, from the ionosphere, the vertical electric field. I've talked about this a number of times on this show. And the situation is that it's very dangerous technology. If there's a solar storm, it's very hard to control, let's just put it that way. Because what Tesla's concept was here was to extract energy from the atmosphere, from the vertical electric field, and then distribute it, the energy underground. And for small localized operations that would work. But on the scale of electricity that we use today, it simply will not work. And it's very dangerous technology. It would kill birds. It would a lot of problems without using that technology. So at any rate, I wanted to show this because I dropped that project because I realized that the same source of energy, which creates the vertical electric field, is the same source of energy that creates wind. And so wind is literally the best energy source, and also it is very efficient. It doesn't create any heat. So whereas with coal or burning any thorium or fusion, any other source of any energy, geothermal, burning nuclear fission products, etc., all of those create heat, and they use the Carnot cycle, which is after you remove all of the inefficiencies and the mechanical inefficiencies, etc., you're around 25 to 23% efficient. All of the rest of that energy going into the atmosphere. So I wanted to show this. Okay, here's some comparisons. Comparative technologies. The Hoover Dam, 2 gigawatt power at full capacity, but when the Lake Mead is empty, there's no power, which they have experienced. So it's a tremendous environmental impact. Hydro dams are very efficient. They're a very good source of power, very reliable, but they depend on the rain. And they built this out in the middle of the desert where sometimes it doesn't rain. And if it doesn't rain up in the mountains that feeds that lake, then you're simply without power. Nuclear generation, a typical nuclear power generator, 560 megawatts, and there's over 75,000 tons of nuclear waste stored in our nuclear facilities because they don't know where to put it. Horrific. Anybody that says that nuclear is green is out of their mind. Simply don't know what they're talking about. And what they're doing is they're saying it's green because it doesn't produce carbon dioxide. That's not the problem with nuclear is this spent fuel, which has to be cooled down constantly. The more you produce, the more you have to put energy in cooling it down. Otherwise, it'll melt through those containers and pollute the world and kill everybody. Nuclear energy is not green by any stretch of the imagination. That is coming from a nuclear physicist. And most nuclear physicists won't say that because their paycheck depends on it. I don't get a paycheck from the nuclear industry, so I can say that. Okay, coal power plant, 500 megawatts is typical. Very inefficient at converting the heat. Stirling engine, which is a solar, like a mirror system out in the desert where they focus the solar energy on a tower and then convert that into electricity. Once again, the facilities that they've built are extremely costly. They only work when the sun is up. A lot of mechanical problems because the mirrors have to constantly be moving to track the sun, etc. And then the three-blade wind turbines, they never could have worked. If you did a real analysis from the very beginning, you would have found out that three-blade wind turbines will never ever solve the world energy project problem. And here's an interesting fact. If the three-blade wind turbines worked, we have about 100,000 of them in the United States right now. If they did work, they would have replaced the coal and natural gas power plants long ago, but they don't work. And so they have yet to even close down one nuclear or coal or gas-fired power plant. Not a single power plant has ever turned off because of wind energy. And there's all kinds of problems with gusting, etc. That's something that is inherent in the design of the wing generator, is that it solves all of these problems. Okay, so 1,000-foot wing generator, anticipated average output of 600 megawatts with peak sustainable output of 2 gigawatts is very small footprint, as you could see in the table just a few minutes ago. And this is the best renewable energy because it doesn't create any heat. The wing generator was written up in Gerald Celente's Trends Journal, and here's just a screenshot of that article. New device harvests water and energy from the air. Okay, I'm running up against the clock here, so I'll continue this show in the future because there's so much more material to cover. It's impossible to cover this in a single show. So we'll talk to you next week and expect some more information on the myth of alternative energy and these related topics. Very important because energy is our number one, something that we have to conquer is energy, and it's doable. It's very much doable, but we need the politicians, we need the people who are tree huggers like myself to realize that the road that we're going down is the wrong road. Three-blade wind turbines and solar will not solve the world energy problem, nor especially will it solve the problem in the first world countries, where the energy demand is growing and growing. So join me in future week episodes where I talk about these and other important issues. Take a second to check out the webpage, jmcannyscience.com. The short URL is jmccsci.com.
This has been Master of Science with host James McCanney. Join us each week as James will delve into historical figures such as Nikola Tesla, Albert Einstein, and the great mathematicians as we explore the history of man, Earth, and our universe as you've never seen it before. Tuesdays, 7 p.m. Eastern, right here on the Bold Brave TV network, powered by B2 Studios.